So next topic is Prim's algorithm, and as we have discussed during minimum cost spanning tree about Kruskal earlier, so you must watch that video before coming to Prim's algorithm. So Prim's has suggested to use the method of same to find out basically minimum cost spanning tree, but its method is different from Kruskal method. So it is also the method for finding a minimum cost spanning tree, but it is different from Kruskal. So how it works basically, same way, before moving ahead, we must look for first if there is any parallel edges. As I have explained in case of Kruskal also, if there is one more edge, let's say cost is 10. So these two edges are parallel edges between B to D. So first of all, we will remove any parallel edge which has more cost. We'll keep only edge which is least in cost. Second, if there is any kind of self loop, let's say there is a self loop kind of things, we will remove this self loop also from our particular graph. So these are the two preconditions, true for Kruskal algorithm also as well as for Prim's algorithm. So before we start either with the Prim's or Kruskal, we will look for parallel edges. If there is any parallel edge, we will remove higher cost parallel edges. We will keep only the lowest cost parallel edge. And for loop, if there is a loop, we will remove that loop also. Once we are free with these two things, then we will start with Prim's concept. What Prim's states, you can start from any particular node. So this particular method does not takes anything related to minimum cost starting, which basically tells in case of Kruskal. In Kruskal, we always pick a ascending order edge cost. So whatever cost of the edge which is less in costing, we pick that edge first. But here we can start from any particular vertex. So let's say we have started with vertex A. If we are starting with vertex A, what is the cost of reaching to B? What is the cost of reaching to C? As this is not a directed graph, if it is directed, we will count into outgoing edges. But it is not a directed graph, so we will take incident edges starting from A and going to which different vertices. So from A, we have one A incidence to B, which is 7 cost, and from A, which is another, which is C, which is the minimum out of 7 and 8, we will pick that particular edge. So A to B, we will pick, we will start with A and we will pick A to B as it is of minimum cost from source A. Now from A as well as from B, we will try to see which edges has what cost. So from B, we can see one edge has cost 6, one edge has cost 3, and from A, we have cost 8. So these are the two vertices right now. We will check, what we will check? Out of incident edges starting from B as well as from A, which has minimum. So out of 8, 3 and 6, which is minimum? 3 is minimum. We will include that particular edge in our solution. So we will take this edge of cost 3 and we will include another vertex C here, or this particular edge here. Now again the same process we will do, starting from A, starting from B, starting from C. What are the different cost of the edges from these three vertices? And we will select always the minimum one. So we can see 8 is still available. From C, we have this cost 4, this cost 3, and from B still we are left with 6. This thing we have already included. So out of this 8, 4, 6 and 3, which is less, C to E is the less. So we will include that particular edge in our solution with the cost 3. Minimum cost edge we will include out of the available all the vertices. Fine. And from here now we have these 4 vertices. So same process we will do again. We will look for B. So cost 6 is available. We will look for C. So 6 and 4 is available. 8 is already available. 6, 4, 8. And from E, we have this 2 and this 2. means two paths available with the cost 2, 2. Any of these two we can pick. So out of 8, 6, 4 and these two and this two, which is the minimum? 2 is the minimum. So either we can take this 2 or we can take these 2. Let's assume I have taken this E to F as it is also carrying 2 cost. So this edge we have included into our solution. So out of now this A, B, C, E, F, we will again use the same process and include the edge which has minimum in edge cost. So from A still we have 8. From B we have 6. From C still we have 4 which we have not included. And from E we have this 2, this particular 2. This 2 we have already taken. This 2 is available. And from F 5 is available. But out of this 8, 6, 4, 2, 5, which one is minimum? So this one is minimum. So we will include minimum cost edge into our solution. Fine. So this is the final answer we got after including this. So this is nothing. This is basically our minimum cost spanning tree. Why? Because it is containing all the vertices in G dash, A, B, C, D, E, F. And how many number of edges it must have? It must have number of vertices minus 1. So in the given graph, 3, 2, 5, 6 vertices were there. So we should have 5 edges in our minimum cost spanning tree. 1, 2, 3, 4, 5. And what is the total cost here? 7 plus 3 plus 3, 13, to 15 to 17, let's say. Fine. So 17 is the MST we have got for this particular problem by using Prim's algorithm. Even if you are following Kruskal algorithm, your answer will be same. It must be 17. So 7 plus 3, 10, 13 to 15 to 17. So this is all about very simple method. Prim's algorithm works by choosing all the vertex and all the incident or outgoing edges from included vertices. And we will take always the minimum cost is including into our particular solution. And there should not be any cycle. That is the prerequisite. So if some edge you are including, cost is less and cycle is forming, we will not include that particular edge in the solution. So Prim's algorithm is second variant of finding minimum cost spanning tree. Thank you.